This video contains two parts. First part will be the microphone and its characteristics. Second part will be the first invented microphone, which is carbon microphone. So let's start.
Good morning everyone. Myself Dr. Shantani Bhattacharya, Assistant Professor of EC Department, SRM Institute of Science and Technology, Kattankulathu, Chennai. Today I am going to start a new subject called Consumer Electronics and Troubleshooting. Basically, this subject is deals with different devices which are basically very much useful for our day-to-day life. So today is the first session of this subject, and after that continuously I will provide some videos based on these subjects. Okay, so today I will start the topic about what is microphone and what is its output characteristics. Okay, so let's start. I hope all of you can learn so many things from this upcoming videos. So keep watching my videos. Okay. So first of all, starting with what is microphone. Microphone is actually transducer. Transducer is actually the machine, that means it converts one signal to another signal. So here, what is this? In the microphone, all of you know, here sound waves actually convert the electrical signal with same frequency of sound waves and shape. Okay, it is useful for many application in day-to-day life, and it actually reacts to a pressure input by use of a diaphragm. That means when sound, there is actually the main criteria is here the diaphragm. There is a thin sheet is there. When sound wave actually comes, it hits the diaphragm, and due to that diaphragm continuously vibrates. Okay, and from there, with the different principle which we will describe in slowly. So from there sound will convert to the electrical signal. Okay, this is the basic meaning of this microphone. So now this is a very important part. What are the characteristics of the microphone? So first of all, important, there are basically 6 important characteristics are very much well known actually. So this is first of all sensitivity, SNR, frequency response, distortion, directivity, and output impedance. Okay, so sensitivity, what is sensitivity? That means how effectively a microphone converts a sound pressure, or you can say acoustic energy, into a electrical signal. Okay, a more sensitive microphone means we can hear the sound very that means output signal is very strong. Okay, and less sensitive means we can get a weaker signal. Okay, and it is expressed in millivolt per pascal, MV per pascal. Okay, now next, signal to noise ratio. Okay, so the difference between the microphone signal level, basically signal to noise ratio definition. What is signal to noise ratio? Signal to noise ratio is actually signal power by noise power. So from this definition, or you can say like that, the first point, that is difference between the microphone signal level and its noise floor, or you can say noise level. Okay, so it is actually, if the noise level is low, then what will happen? Then we will get a better sound at the output section. Okay, so this is actually the first part. So better, not better sound, better signal at the output section. So if the noise level is very high, then we will not get a proper signal. So it is measured in dB. That means already it is mentioned at higher SNR indicates a clear signal with less background noise. I have already told this one. Okay, so choose a microphone with a SNR of 70 dB or more for good quality. Proper setup and noise control help maximize SNR in real world use. Okay, so to increase the signal to noise ratio, we have to reduce the noise in any way. So, but we have to reduce the noise. So only that, only for this purpose, the output signal we will get a very good output signal. Okay, so now this is a frequency response. What is frequency response? The measure of, that means it is actually the how the output voltage actually represent in the case of different sound waves. Okay, so that means it is already said that this measure how faithfully the output voltage represents sound wave across different frequency. It is actually the plot of output voltage versus input frequency. That means with the input is a sound wave, how with the different sound waves, how the output signals also varies. It is basically, this is called the frequency response. That means output wave curve, that means with respect to frequency. Okay, good modern microphones are relatively flat over the entire range of the frequency. The range of frequency a microphone can capture is usually expressed in 20 Hz to 20 kilohertz. This is actually the our audible voice. Okay, so distortion, microphone distortion refer to the unwanted changes in the audio signal causing inaccuracy in sound production. Okay, so there are basically two types of distortions are there. One is harmonic distortion and another is phase distortion. So first one is harmonic distortion, like that total, you can say harmonic distortion or total harmonic distortion. Okay, so it is created by distorted harmonics in amplitude. Percentage should be less than 0.5% and lower TDH, that means total harmonic distortion, means cleaner audio reproduction. Okay, so and that means lower TDH means cleaner signal we will get at the output section. Phase distortion happens when different frequencies of sound arrive in a same time, different time. Okay, so more common in multi microphone setup where phase alignment is not properly managed. Okay, then directivity, this is very important part of the microphone principle. Okay, so what is directivity? Directivity is actually where from the sound waves which are coming from different basically different direction, and for microphone that captures how this sounds. Okay, whether it captures from all direction or it captures a particular direction. So this is the main point of the directivity, in which direction sound wave actually comes and capture. It is the main principle. So what is the omnidirectional? Omnidirectional meaning, omni means actually all. So all means, what is this? All means actually at that time it actually this type of microphone captures the sound from all direction. Okay, so what is that means, already I have mentioned that omnidirectional microphones are equally sensitive to sound from all sides, picking up sound from every direction. So when sound wave are coming from all direction, then what will happen? Then there will be some noise effect, because there are different, when I am speaking in a class, then what will happen if there are other sounds will also come in other direction, then last bench student cannot hear properly my voice. So this is the problem in that case. Okay, so omnidirectional microphone application area is good for ambient sound and group vocals. Okay, then next, cardioid microphone. Okay, so this is the pattern of cardioid polar pattern or microphone. So here it is looks like a heart shaped. Okay, so this is, so it is also called the heart shaped microphone also. Okay, so it actually, here you can see it actually accepts the sound from the front direction and little bit side, and rejects the sound from the back direction. Okay, so here what is the meaning here? Whatever you have written, I have just go through it. It is sensitive to sound only in a specific direction. The most common type feature a cardioid, that means heart shaped pattern that rejects sound coming from behind the microphone. Already I said sound is picked up mostly from the front, I've already said, but to lesser extent from the sides. Few amount of sounds also from sides. Cardioid microphone are very versatile microphone, ideal for general handheld applications. Okay. Basically, handheld application means different types of sometimes. We are using the microphone in our dress like that. This is called handheld. Okay, so this is the application already complete. Now we are coming to the hypercardioid microphone. What is this? This is the pattern of the hypercardioid. So what is this? Here you can see from this pattern you can tell that sound waves coming from the front direction and a few amount of very few amount of rear direction or back direction. Okay, so what is this? The hypercardioid microphones are an overstated version of cardioid pattern. It is very directional and elements most of the sound from the sides and back. Okay, due to the long thin design, they are often called shotgun and rifle mics. Okay, it looks like a shotgun. Okay, these are very useful for isolating sound from a subject or direction when there is much ambient noise. Okay, so basically we will in our next after some next 2 or 3 videos we will discuss about the shotgun or gun microphone. There basically this hypercardioid microphone principle basically used. Okay, so here at that moment you have to understand this. When we will discuss about the gun microphone, it will be more clear. Okay, so they can it is a basically application area is to pick out sound from a subject at a distance, long distance. Okay, then output impedance. Okay, microphone output impedance refer to the resistance which is noted as ohm that present in a audio circuit. Okay, to avoid the signal loss, microphone output impedance and input impedance should be matched. Okay, so mismatch impedance can cause weak signal distortion or tonal changes. Okay.
Now we will start the second part of this video, which is based on carbon microphone.
So, what is carbon microphone? Carbon microphone is actually the first discovered microphone. It was developed in 1870 by Englishman David Edward Hughes. So, it was first reliable form of microphone and it was widely used for many years. And that means in many application before actually discovered any other high level microphone. Okay. So, what is the basic principle of the carbon microphone? So, here you can see that this is actually the microphone basic principle construction. Actually, here it is given. So, what you can see from here, that here sound waves, actually it is a microphone, that means it is a transducer that converts sound wave into an electrical signal. So, here sound wave definitely will hit the diaphragm. This is a thin diaphragm in the front direction, and in the back direction there is a fixed electrode is there, and between this same diaphragm and electrode there is a carbon molecules, or sorry, carbon granules. Okay, so what will happen when sound waves hit the diaphragm? Then what will happen? This is a thin diaphragm, so it will actually vibrate. So due to the vibration, due to this vibration, this fixed electrode and diaphragm, the distance will reduce, and inside this there is a carbon granules, and in the case of carbon granules there is a very interesting properties. So what is this properties? That means when carbon granules actually comes closer together, then it resistivity lows. So when resistivity lows, then what will happen? A more current will pass through this device. Okay, so here first point is carbon microphone comprises carbon granules contains within a small container covered with a metal diaphragm. This is already I said, this is the carbon granules, diaphragm, and this is the electrode, fixed electrode. Basic concept behind carbon microphone is that when carbon granules are compressed, resistance decreases. This occurs because the carbon granules come into better contact with each other when higher pressure pushes them together. That means higher pressure comes from this sound waves. So when sound waves come, when they hit the diaphragm actually give a pressure on the carbon granules. Okay. So what is the next? Here battery is very important. Battery is also required to cause a current to flow through the microphone. Okay. When now is working principle they are describing. So when sound wave strikes the carbon microphone diaphragm, it vibrates, exerting a varying pressure on the carbon. Then these varying pressure are translated to the varying level of resistance. Why it is varying level of resistance? I have already told that sound waves coming, it actually hits the diaphragm. So diaphragm actually there is a pressure, or the sound wave also sometimes is high, sometimes is low. When we are actually speaking, then sometimes voice will be very high, sometimes voice will be low. So based on these pressure also it will vary. Okay, so when pressure will vary, then it actually hits the carbon granules, so there also resistance value also varies. Okay, which in turn vary the current passing through the microphone. Okay, so resistance varies, that means current also varies. When resistance high, current low; when resistance low, current high. So varying current can be passed through a transformer or a capacitor to enable it to be used within a telephone or by some form of amplifier. Okay. So now what are the advantages? Can produce a strong electrical signal without extra amplification. Okay, and you can see the construction is very simple, so it is very useful for all case. Okay, and it is very cheap. Okay, so very cheap and simple manufacturing process. So these are the advantages of carbon microphone. Now next is disadvantages. This is very noisy because high background noise, and on occasions it would crackle in sometimes. Okay, so poor frequency response and requires continuously battery backup is very important. Battery is very important. So these are the disadvantages. So now what are the applications area? Due to the limited frequency range, it is very much useful for only telephone parts, and it is also sometimes used in portable radio communication set. Okay, so thank you so much. Keep watching my video. If you have any doubt, then you just give me this your doubt in the comment section. I will try to solve this doubt. Thank you so much. Keep watching.